Alright, so we're going to look at using rational equations to solve a word problem right now. So this is example 3 that's on page 255. So what's in this case, I've got Stuart and Lucy working together to deliver flyers, and when they work together they can deliver all of the flyers in 42 minutes. Okay? I'm also given that Lucy can do the job in 13 minutes less than Stuart when she works alone. So I'm given Lucy's time in relation to Stuart's. So that means I will call Stuart X, and Lucy will be 13 less than X, so that's X minus 13. So now what I'm going to do is find the unit rate for how efficiently these people work so that I can set up a rational equation. So think about this for a second. If it takes me 10 minutes to do a full job, then that means in 1 minute, if assuming I work at the same pace every minute, I should get 1/10 of the job done each minute, right? So using that thinking, if it takes Stuart and Lucy 42 minutes to do the full job, then that means in 1 minute they should just get 1/42 of the job done. Okay? Alright, let's say Stuart takes 50 minutes to do the job. Then that means he would get 1/50th of the job done in a minute. If it's 60, it would be 1 over 60. So whatever this number is, it's 1 over X that he gets done in 1 minute. Same thing with Lucy, so this would be 1 over X minus 13. Now, you note that Stuart and Lucy work together at this rate to give you this number. So there's my rational equation. It's 1 over X plus 1 over X minus 13 equals 1 over 42. Okay? In this case, I look at my denominators. My denominators are X, X minus 13, and 42. These denominators are all completely different. These actually aren't similar, even though they look like they can be. If you think about it, in order to get common denominators, we only use multiplication. So you can't just take 13 off of that and make it look like X minus 13. It's only multiplication permitted, okay? So if you look at multiplication, these three things are completely different. So that means my least common denominator in this case is just going to be the three of them multiplied together. So it looks like that, right? So now what I'm going to do with my common denominator is I'm going to multiply it by each piece in the equation. So I'm going to take the 42x, X minus 13, multiply it by the first piece. Then take the 42x, X minus 13, multiply it by the second piece. Excuse me. And then take the 42x, X minus 13, and multiply it by the last piece. I can simplify a little bit here, because I can see that this x will cancel with this x right here. Not this one right here, because this one has minus 13 attached to it. I can only cancel multiplication and division, not subtraction. So this x cancels with that x. Likewise, this x minus 13 can cancel with that x minus 13. This 42 cancels with that 42. That leaves me with 42 x minus 13 right here. Plus 42x right there, and x times x minus 13 on that side. Using my distributive property now, so this will be 42 times x, which is 42x, 42 times negative 13, which is negative 546, plus my 42x, that's already there. Then I'm going to distribute over here. X times x is x squared. X times negative 13 is minus 13x. What I can do now is I can group these two x terms together. They're like terms. So 42x plus 42x is 84x. And now I need to set this up as a quadratic equations. Remember, quadratic equations look like this. They have all your terms written on one side of the equal sign. So what I can do is move these things to the other side. So this is a positive 84x, so to get rid of that I would subtract 84x, because 84x minus 84x gives me 0. But if I subtract 84x from this side of the equation, then I've actually thrown the balance of the equation off. So to balance it out, I need to subtract 84x from this side. This is a negative 546, so to get rid of a negative 546, I'd have to add 546. That gives me 0. Of course, to balance that out, I'd have to add 546 to the other side as well. So then that gives me 0 on this side, and then I've got x squared minus, negative 13x minus 84x, well, that's minus 97x, and then plus 546. Okay? So at this rate, I can see that my A value is 1, my B value is negative 96, my C value is 546. Okay? Then I can just use the quadratic equation to solve for x in this case. Alright, so of course the quadratic equation is this.
Sir, back yet?
For AC all over 2A. Okay?
I just don't making that video.
So now you can go ahead, use the quadratic formula, plug in your A, your B, and your C to see what this gives you. So then you'll come out with x equal to 6 and x equal to 91. So at this point you think about which of these answers makes sense. Well, remember, x is how long it takes Stuart to do the job. So if I subtract 13 from x to find Lucy's time, well, this is going to give me a negative value, right? It can't take negative time to do a job, so as a result this value cannot possibly be Stuart's time. This means that Stuart takes 91 minutes to deliver the flyers, and then to find Lucy's time, I can just take 91 and subtract the 13, right? So that would then give me a 78. Okay?